Welcome back to another training video using the UK Electrical Simulator. In the previous video, we looked at adding an intermediate switch between two two-way switches using the three-plate method. In this video, we will look at the same intermediate switching principle, but this time using a two-plate circuit. We will also look at another two-plate arrangement, often called wired through the switch, and compare how the two versions differ. With the three-plate method, the supply is taken to the ceiling rows first. From there, a permanent line is taken down to the switching arrangement through the first two-way switch. A switched line then returns to the ceiling rows to energize the lamp or group of lamps. All three switches can change the state of the lighting circuit, turning the lamps on or off from three different locations. Now let's move on to the two-plate method. In this arrangement, the three switches are wired together in the same way, so let's start there. Connect the two COM terminals on the two-way switches together, using the back box connector on the intermediate switch as the joining point. Next, connect L1 on the first two-way switch to L3 on the intermediate switch. Then connect L2 to L4. Now connect L1 on the intermediate switch to L1 on the second two-way switch. Then connect L2 to L2. Finally, connect the CPC between the earth terminals on all three switches. That completes the switching arrangement. With the two-plate method, we take the supply directly to the first switch position instead of taking it to the ceiling rows. Connect L5 on the bus to L1 on the first two-way switch. This provides the permanent line feed into the switching arrangement. To connect the neutral conductor, double-click on the first two-way switch and add a back box connector. Then connect N5 on the bus to the C connector. Finally, connect E5 on the bus to the earth terminal on the first switch. We now have our supply feeding the first switch position. The final step is to connect the first two-way switch to the first lamp and then extend the conductors across to the other lamps. Connect L2 on the first two-way switch to the SWL terminal on the first lamp. The simulator may color this conductor blue with brown sleeving. If you want to change it visually, press Alt-C to cycle the conductor color and Alt-B to toggle the sleeving on or off. Now connect the neutral from the N terminal on the first lamp down to the back box connector C in the first switch. Then connect the CPC between the earth terminal on the first lamp and the earth terminal on the first switch. We can now extend the conductors to the other two lamps. Once that is done, we can energize both the C5 and C4 circuits and compare the animation. Both arrangements energize the lamps, but the supply is fed into the circuit at a different point. In the three-plate method, the supply is taken to the ceiling rows first. In this two-plate method, the supply is taken directly to the first switch position. However, the switching principle is the same. The two two-way switches remain at either end of the switching arrangement, and the intermediate switch sits between them. If we toggle all three switches into the same positions on both circuits, we can see that the animated current path through the switches follows the same route. If we operate the switches again, the route changes in the same way on both circuits. The wiring layout is different, but the switching action is the same. Now let's disable both C4 and C5 on the bus components and pan the screen across to the third circuit. This third circuit shows another two-plate option, often called the wired through the switch method. With this method, we still take the permanent line supply to the first switch. However, this time we connect it to the COM terminal on the first two-way switch, rather than to L1. The neutral is still used for the return path for the lamps, but is first routed through the switch positions using the back box connectors. The switched line to the lamps is taken from the final two-way switch, rather than from the first switch. Let's wire the circuit. First, connect L5 on the bus to the COM terminal on the first two-way switch. Then connect N5 to the back box connector on the first switch. Finally, connect E5 to the earth terminal. In this method, we need a back box connector at each switch position. This allows us to carry the neutral through the first switch, through the intermediate switch, and across to the final two-way switch. For the neutral link between switches, it is good practice to use the grey core with blue sleeving. A black core could be used if correctly sleeved, but grey with blue sleeving is commonly used for neutral in this type of cable arrangement. Now we can connect the live switching conductors between the switches. The process is similar to the previous methods, but because we have used the grey core for the neutral, we need to make sure the remaining switching conductors are identified correctly. Connect L1 on the first two-way switch to L3 on the intermediate switch. Then connect L2 to L4. If needed, change the conductor colour using Alt-C and make sure any live conductors are correctly identified with brown sleeving. Next, connect L1 on the intermediate switch to L1 on the final two-way switch. Then connect L2 to L2. Again, make sure the conductor colours and sleeving clearly identify these as line switching conductors. Finally, connect the CPC between the earth terminals on all three switches. The switch wiring is now complete. The next step is to connect the final two-way switch to the lamps. Connect the COM terminal on the final two-way switch to the SWL terminal on lamp 3. Then connect the neutral from the N terminal on lamp 3 down to the back box connector C on the final two-way switch. Next, connect the CPC between the earth terminal on lamp 3 and the earth terminal on the final switch. Now extend the conductors from lamp 3 across to the other two lamps. Finally, extend the CPC from lamp to lamp. Now turn on C5 on the bus to energise the circuit. You will see that both two-plate methods energise the lamps, but they use slightly different wiring arrangements. In the first two-plate method, the permanent line, neutral, CPC and lamp cable are all brought to the first switch position. This works, but it can make the first switch box more crowded. In the wired through the switch method, the supply enters the first switch, passes through the switching arrangement, and the lamp connection is taken from the final two-way switch. This can reduce congestion because the cabling is spread more evenly across the switch positions, with fewer cables needing to terminate in the first switch box. So the key point is this: both methods achieve the same result. All three switches can control the same group of lamps. The difference is not how the switching works, but where the supply, neutral and switched line connections are routed. I hope you enjoyed part 2 of this video series, where we looked at two versions of the two-plate method with intermediate switching. Please like, subscribe, and leave a comment below.